Hello. Hi, Shivani. I hope you're doing well. The questions that you've asked me, let me just solve that question for you. Okay. So the question that you've asked me is, I think this one, that is n equals to 1 to infinity, n raised to power 1 by n minus 1. Um, I think that this particular question has been asked by you, and you are saying that this particular question should be a divergent. So yes, indeed, it should be a divergent. Okay, but let me just solve for you a more general case. Okay, so a more general case I'm going to solve. And what would be that? Okay, just see that. So the more general case would be, I'll do this question for you. That is, uh, I hope you are well versed with calculus, that is differential calculus. So I would use some differential calculus here. Okay, and if I'm going to use differential calculus, you need to pay attention to it. Okay, just pay attention to whatever I'm saying right now. Okay, so see, okay, so the claim is, so my claim is that this would be a divergent series if alpha is less than equal to 1 and greater than 0. And the claim is based on an inequality that I'm going to derive. Okay, that I'm going to derive. Don't worry about it. That I'm going to derive. But just pay focus on this. Just pay attention to this. Okay. So you asked me a question that is summation n equals to 1 to infinity n raised to power 1 by n minus 1. This particular question, if you are asking, this particular question is going to be a divergent series. Okay. How it would be a divergent series, that I'll let you know. But just pay attention to this particular thing that I'm going to write just now. Okay. So, see, in order to solve this, I'm just doing a general case where I'm doing this. And now I'm trying to solve a few questions, a little bit for you. So, solution. Okay. So, see, I'm just writing right now that understand that ln n will always be less than n into n ki power 1 by n minus 1. Okay. Okay. Therefore, since it is this, so therefore for all n greater than 3, why I'm taking greater than 3? Because if x is greater than e, that implies what? That implies x greater than e means greater than 2.7183. And now I'll instead of doing all these n, I'm going to write x here. Okay, so I'm going to consider some function f of x, which is defined on real numbers. Okay, so however, the sequences are functions from natural numbers. So for all n greater than 3 also, what I can say, for all n greater than 3, what I can say that ln n will be greater than ln 3. Yes, and ln 3 would obviously be greater than 1. So I can write that ln n would be greater than 1, and it is less than n raised to power n ki power 1 by n minus 1. Or in other words, I can say that ln n upon n will be less than n ki power 1 upon n minus 1, and here it would be 1 upon n. Okay, so now just place alpha all over side. So I'll get 1 upon n raised to power alpha here, and here I will get ln n upon n raised to power alpha, and here I will get n ki power this minus 1 upon n. Now you know from comparison test that if alpha lies between 0 and 1, this series would be divergent. And if this is divergent, then this will be divergent. Then summation n equals to 1 to infinity n ki power 1 by n minus 1 raised to power alpha would be divergent. When it would be divergent, it would be divergent if alpha lies between this. Now you would say that, okay, you've done the solution. Probably you may know the answer for this. Yes, indeed, I know an answer for this. But see, this particular part you have to remember. Now, this would be a difficult thing to do in exam. So obviously in exam, these all things will be given to you in options. Don't worry about it. Okay. Now you see, in order to explain this, I will have to go a little bit into calculus, and let us see how do you be able to understand this. Okay. So let us first develop this inequality. Let us first develop this inequality. Okay, let us first develop this inequality. So how to develop? So I'll consider a function. Consider a function defined from 0 to infinity to r. Why 0 to infinity? Because first I'll take this as a function. Then instead of x, I'm going to replace this n. That was natural number. So I'm going to take a function which is f of x is equals to what should I write? I should write log of 1 plus x minus of 2x upon x plus 2. So this is my function. Just remember this, okay? Just remember this. So if I differentiate it, what I'll get the, if I do the derivative, so I'll get 1 upon 1 plus x. Here I'll get the derivative 2 upon x plus 2. And then I will get, I think, plus 2x upon x plus 2 whole squared. And which would imply x plus 2 will go there. So I'll get x plus 2 minus 2x minus 2 divided by x plus 1 into x plus 2 plus 2x divided by x plus 2 ka whole square. And I think little bit of calculation you may do, I have already done. So I think you'll be able to understand that this particular f dash x would come out as, this is something that I've done before you gave me this question. So don't worry about it. You can do it on your own. So f dash x is greater than 0, which implies fx is an increasing function. And fx is an increasing function for all x greater than equal to 0. So it implies fx will be greater than equal to f of 0. And what is f of 0? Just place 0 here, log 1 is 0, 0 here, so it is 0. So what I would say, so I'll say that log of 1 plus x will be greater than equal to, so I'll write minus 2x upon 1 plus x would be greater than equal to 0, because f of 0 is 0. You can check it your own self that log f of 0 is equal to 0. So this is clear. So this is it. So log of 1 plus x will always be greater than equal to 2x upon 1 plus x for all x greater than equal to 0. Okay, this is it. Now you see another inequality that you should be knowing, I think by now, that log of 1 plus x is always less than x. Okay. In order to develop it, just take a gx, and this I'm considering for all x greater than equal to 0. So let us consider g of x is equal to log of 1 plus x minus x. Take a derivative of it. The derivative of it will come out as 1 upon 1 plus x minus 1. And what you will get, if I take this derivative, so I know that this is, I'm going to get minus x upon 1 plus x. Indeed, it is negative because x is positive. If x is positive, this is positive, this is positive, there's a negative. It implies gx is a decreasing function. If gs is a decreasing function for all x greater than equal to 0, g of x will be less than equal to g of 0. And if g of x is less than equal to g of 0, this is log of 1 plus x minus x will be less than equal to, what is g of 0? Log 1 is 0 minus 0. So it will be less than equal to 0. That implies log of 1 plus x minus x will be less than equal to 0, which is log of 1 plus x will be less than equal to x. Okay. So in general, always remember that for all positive values, if you just remove 0 here, that is, don't use 0, because after all, when I'm going to use, instead of x, I'm going to use natural number, then natural number are obviously greater than 0, strictly greater than 0. So I'll write log of 1 plus x is always less than x. It is greater than, I think, 2x upon x plus 2. I think this has been asked in your previous exam as well. This particular inequality has been asked. I don't know exactly, but probably this is a very established sort of inequality. You should remember this. Okay, now once you remember this, now let us move to a few more things. See, this I think you should remember. Okay. Now let us get back to the problem. Okay, so what was the problem? Problem was this, which I've already solved, but I have to prove that log n is less than n into n ki power 1 by n minus 1. This I have to prove. Okay, now let us see how it goes. Let us see how it goes. Okay, now just for time being, consider x is equal to a ki power n. An. X is equal to an. Now instead of x, I'm writing an. And what is an for me? An is n ki power 1 by n minus. Okay, and remember n ki power 1 by n minus 1, what it will be? You just see at n equals to 1, it is equal to 0. At n equals to 2, this will be root over 2 minus 1. Okay, at n equals to 3, this will be 3 ki power 1 by 3 minus 1. At n equals to 4, it will be 4 ki power 1 by 4 minus 1, so on and so forth. Okay, and the limit value would be 0. Why it will be 0? Because this limit is 1. This is also a separate question itself. Don't worry. So just for the sake, just for now, time being, I'm writing x is equal to an, and an is equal to n ki power 1 by n minus 1. I hope it is clear. Okay. So this is, I think, I'll prove you someday. I mean, this is also a good proof. We'll do it some other day. But just for this, that this limit is equals to 1. So that I'll do later on. Just place instead of x this an. So if you do so, what you're going to get. No, not do that. Let me just solve it for you so that you'll get some. So एक काम करते हैं ना, इसको an plus 1 is equals to n raised to power 1 by n, and now take both side power n. So this will be like this, is equals to n. Okay, and now I can write that if I use log here, so log of n is equals to 1 upon n. This is how it is. And remember, I've already taught you that this will be less than this particular thing. Log of 1 plus x is less than x. So instead of x, you're writing an. So I can write that log of 1 plus an will be less than n an. Okay, log of 1 plus an will be less than, if I'm not wrong, I've done something wrong somewhere, I don't know. Oh, I think this is not 1 by n, this is simply n. So if I take log on both sides, so log of n will be n log of 1 plus n. And since this will be less than, so this, I think this is clear now. देखो log of n बेटा क्या होगा? Log of n क्या है? n किसके बराबर है? ए n plus 1 की पावर n आ रहा है ना, दोनों साइड log लोगे तो log n equals to क्या आएगा? n आगे ले लो, log of a n plus 1, और log 1 plus x इससे छोटा होता है x दोनों साइड की. I think this is quite clear to you. Okay. Okay, since this is quite clear, now what was an? Don't forget that an was what? N की power 1 by n. So I'll write n into n की power 1 by n minus 1. Okay, so your n log of 1 plus an would be so. And what is your an, by the way? So an is what? Oh, sorry, I have not written this here. So if I use this, I will get n की power 1 by n. So if I get n की power 1 by n would come outside. So this would be log n is less than n की power n into n की power 1 by n minus 1. I hope it is clear. Since it is clear, then what I can do? Then see, I'm not going to use now general result. I'm going to use your question. So log n will be less than n की power 1 by n minus 1. Is that clear? And always remember, see, this is your log graph. This is how your log look like. And this is how your, so log will tend towards infinity. Okay, log will tend towards infinity. This is clear. And it will always, if I just compare, see, this is e, and around at x equal to, sorry, this is 1, and at x equal to e, this will be 1. So for all x greater than e, I can write that log of x is greater than log of e, which is 1. And if I use this in natural number, I can write for all n greater than e. So e के बाद natural number कौन सा था बेटा? 3 आएगा ना? So for all n greater than 3, I can write that log of n would be greater than 1. This is how it is. देखो ध्यान से देखो, मैं क्या समझाने की कोशिश करूँ वो समझने की कोशिश करो. लॉग एन किससे बड़ा होगा बेटा? 1 से बड़ा होगा कब? जब n 3 से बड़ा हो. ये चेक कर लेना खुद से, बहुत आसान चीज है. नहीं है तो मुझसे पूछना. सो ये हो गया आपका. नाउ यू सी, it implies what? It implies 1 upon sorry, n की पावर 1 upon n minus 1. ये हो गया. This is divergent. It implies this is divergent. I hope I have solved this problem for you. Please, 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 this is a request. I'm just trying to build an ecosystem which is called as Sarthak, as I told you on the group. Please try to add as many as add people around. Okay, so if once I have around 50 students, I will surely start a free batch. And this, wherever you are studying right now, even if you're studying at an academy of whichever institute right now you are studying, I promise you the content will be a lot more different. Okay, and it will be free. Okay, even if you cannot listen to your these classes, that is the live classes, you can go for the recordings. Okay, I would need a few people around, but in general, if you join this initiative, I am promising you that your real analysis part plus DE part will become rock solid. Okay, you're going to perform like anything. But still, if you have some doubt, please let me share that out to me. Okay, till then, take care. Bye-bye.